Astro30 here yet again with a brand new video for you. Now today on the lab I want to talk about a amplifier phenomenon that is quite commonly documented and quite commonly documented with solutions. That is one of thermal runaway. What is thermal runaway, I hear you ask, if you don't already know? It's when the output stage transistors start dissipating more and more heat into the heatsink to the point where the heatsink just becomes totally red hot and eventually the output transistors will fail. They usually fail short circuit. Three things can actually be done to solve the problem. First and foremost, you need to make sure that the amplifier is not oscillating. I do not believe this amplifier is oscillating. Secondly, having degeneration resistors on the output transistors helps with the thermal stability. They're already there. Finally, having two diodes or a VBE multiplier in contact with the heatsink to actually control the bias. So, what do I mean? Well, put simply, here is a drawing of a basic output stage. Now, I haven't shown the driver transistors here. For all intents and purposes, assume these two transistors are Darlington for the sake of argument of this discussion. Now, this is a standard topology of biasing an output stage. Up here, that's a constant current source. In most cases, it can just be a resistor, but it can also be a transistor. So I've just shown that as this like 8 symbol, meaning that it's a constant current source. So that is actually irrelevant to what we're doing here. We'll notice these two diodes, which is basically a VBE diode self-biasing network, if you want to call it that. Now the way the amplifier will adjust the bias of the output stage, these diodes really need to be in contact with the same heatsink that these power transistors are mounted to, or to the body of the drivers, whichever. And as the heatsink or the transistors heat up, with these diodes in close contact with the same transistors, these will also heat up. What happens then is as these diodes heat up, they will conduct more and therefore lower the actual current flowing into the base junctions, and that controls the thermal stability. And as we can see here, we've got the two degeneration resistors anyway. That's one way of doing it. However, mounting these diodes to the heatsink can be, well, somewhat challenging to do considering where the diodes are located on my circuit. There is another alternative I can actually do, and that is actually include a VBE multiplier. This will work exactly the same way as the diodes, except if you use something like a BD139 for instance, it gives you a convenient way to mount that transistor to the heatsink to monitor the temperature. Again, it'll do the same thing as the two diodes if they're in contact with the heatsink. As soon as the heatsink starts heating up, this transistor will start heating up. It'll actually start conducting more, and the voltage and current going into the bases of the output stage will lower. You can demonstrate that by having this left off the heatsink, have say a 100 ohm resistor in series with the positive, put a multimeter across that resistor measuring the drop, and with it idle, not connected to a load and no input signal, if you were to touch the collector of that BD139 transistor, you will notice that the voltage drop across the series resistor will start decreasing as well, indicating that the current is being decreased in the output stage. So that proves the theory that when this transistor starts heating up, it will start to conduct more, and yet the current will go down. And I think conveniently I can mount a BD139 just above these two drivers upside down, which actually is even more convenient because the emitter is on the left of the device, which means the emitter will now be, because this is upside down, facing this direction on this side, which is close to the negative point, which is where it needs to go. It needs to actually connect to the base of the PNP transistor on that side. And the collector needs to connect to the base of the NPN transistor on the positive side. Win-win situation. However, what values should I use? Well, you can make this adjustable. Usually you put the adjustment down here. It's never usually a good idea to put it up here. I've seen most power amp designs with a 1K and a 2K trim pot. So if it was balanced with two 1K resistors, that puts the bias point equal in the middle. So it should be fine. This capacitor is only there for high frequency filtration. It can be as small as a 100 nanofarad capacitor. That'll work just fine. So the only thing to do would be to actually build this little circuit up on a piece of Veraboard, because that's all I've got. And what I'll do is I'll remove the diodes that are in there, and I'll just run two small bits of hookup wire to the original points of the anode and the cathode on the other diode, respectively, to connect the VBE multiplier in circuit. Will it blow the amplifier up? Nah, shouldn't. And a short time later, there is the VBE multiplier built up on a piece of breadboard. I'm not sure whether this capacitor is needed or not yet, but it's there anyway. Base is over here, emitters over there. Got the two resistors forming the voltage divider in circuit there across the base. The common point is the base. The red wire is connected to the collector, the black wire is connected to the emitter. So when it's put in the circuit, it'll be put in upside down. Now I've left the transistor leads and the capacitor leads long like that so I can reclaim the parts and put them on a proper PCB. All this is for, at the moment, just for testing purposes. Probably means I'm going to have to rework this board twice. I may be able to get away with reusing these wires if I can strip them back a little bit shorter without having to unsolder them. So the next task is to unsolder the two diodes and solder these two wires in its place. And well, I do have to take this apart to drill another hole to mount the transistor, but for now I'll just find a way of making it connect to the heatsink without having to do too much manual work. I mean, I know that's lazy, but yeah, that's me. Right, well, the VBA multiplier is actually in there. I did it properly. I drilled a hole in the heatsink and actually mounted it through the heatsink. All I've got to do is just tighten up these output transistors, and then we can test it. There's only two things that can happen. It either works or it blows up. Alright, I've got everything set up, and I don't think the latter's going to happen, but I've got everything set up. Got two safety resistors across each power rail. That's pretty close to the power supply. I've got the multimeter going across the positive one to measure the voltage drop. I don't really want to see any more higher than 4 volt DC because this is a different circuit to what was in there. So without further messing around, I'll plug it in and be ready to unplug it. Oh, perfect. Look at that. It's still remaining at around about the 7 milliamp volt range. So if I touch the input, see, it's dancing around. So I know it's still functioning as an amplifier, so that's all right. So now I guess we do the original sound test that I did in the first place that caused this to overheat and see if it now maintains, well, a better thermal stability. Alright, got the speaker set up on the floor, and I've got all the amplifiers set back up on the bench like I had it the other day. However, I've decided to move where things are grounded. So I'm taking all the grounds off of the star off of the power amp, which is already a star ground. So hopefully that will alleviate the mains noise. But I'm going to plug it in and make sure that master is turned all the way down. Plug it in. There is no noise. No noise at all coming out the speaker, which is good. And the preamp works. Alright, I think we're in business. No mains hum, Excellent. So, nothing seems to be happening yet. Need to adjust the action of the bass a bit, I think. Still cool, so that's alright. The rattle is the screws in the handle. Okay. Alright, it's slightly getting warm, but it's not hot to the touch yet, so I think the VBE multiplier is doing its job, and it's kept the current down where I want it to be, which is 7 mA. May seem a bit low, but it's going towards the point of cut-off. I'm out of practice on that song. And the heatsink, after 5 minutes, is remaining relatively cold, so I think I've solved the issue. So what I might do is I might leave that running for 5 minutes, just amplifying the buzz that the guitar's producing, and then come back in a few minutes and reheat test. Dick sack paddywhack. Alright, that's been running for a good 5 minutes, just amplifying that buzz, and if anything the heat sink has cooled right back down to cold, so it's perfectly fine. So I believe I've solved the problem now, and I knew it would. So the amplifier is not oscillating. Let's get that straight. I've got rid of that annoying mains buzz because everything is now hooked back up to the power amplifier ground, which is a star earth anyway. So when I have the front panel PCB made, it'll have a copper ground plane on the back of it with a hole, I suppose, for a screw to go through, which will be the grounding point for it, and I'll just simply run a ground wire. I can't actually get a ground wire, two of these wires into the same connection point. So I'd have to run one back to the power amplifier and then run another one back to the front panel. But it all still returns to this point. That deserves a beer. Cheers. Well, it's the end of the day anyway. Now, is it the prettiest looking thing in the world? No, but it gets the job done. As I said, I will have a proper PCB made. I've actually done the layout off camera anyway. But I'm not going to pay the $12 shipping just for a small board like that. Pardon me. I'll wait until I do another PCB order. I've got to finish my variable lamp power supply anyway, so there's a PCB going to be made for that, so I'll order that at the same time next week. Double adapter, female acceptor. But the two main issues that I had with this before was getting rid of the mains hum for a start. That is now solved. Keeping this heatsink cold when it's not actually doing anything was also an achievement that I wanted to do, and I achieved both. Yay me. So anyway, I know I didn't really go into all the details of how the VBE multiplier actually works. There are other videos on YouTube of people that can explain it better than I can. John Audio Tech is one that can actually explain all the technical design parameters of an amplifier, including VBE multipliers or bias spreaders, whatever he wants to call it. He'll go and explain how all the current flow and how it changes its current flow due to heat, and basically how it all physically works. I have explained it as to what it actually does, which is when it actually heats up, it changes the amount it conducts, which means it conducts more. Therefore, it starts limiting the current going into the bases of the output transistors, which is in the whole entire point. And that in turn will keep the thermal stability of the amplifier reasonable. So yes, if you build this amplifier, you don't have to do what I did. Just simply run the two diodes out the bottom of the PCB here, in the correct orientation of course, and just make them come into contact with the heatsink with a dab of heatsink transfer compound. I've gone through this method of bolting it to the heatsink because remember, this is going into the speaker cabinet. So having those diodes floating around loose, they may over time cause them to vibrate away from the heatsink, therefore making no longer thermal contact. Anyway, I'm just rambling on now at this point, so I'm going to end this video here. And if you enjoyed it, please remember to go down the bottom here and rate and subscribe if you haven't already subscribed. I would like to get to 2,000 subscribers by the end of this month, and then I'll do a special AMA. You can ask me anything and I will answer most of those questions within reason to the best of my ability. So anyway, this is Yasho 30 saying, see ya, thank you for watching. It's a great day today.